All right, let's begin. This is the review for the final exam. And for those of you who have asked, and several of you have, yes, the final exam is required of everyone. We did have to make changes to our original syllabus. We were going to have 3 tests and then an optional final exam. But unfortunately, as you know, things changed, and we're only having 3 tests, the third being the final exam. There are going to be 31 problems on this test. They are going to be in the Hawks format. You will have 2.5 hours to do your test, and it is, once again, just like the last test, uninterrupted time. Once you start, the clock is ticking, and you have 2.5 hours to finish. There is a departmental review posted online. This is my personal review, and this is the one that I would encourage you to focus on. Why? Because every problem on this review will have a corresponding problem on the test. If you get familiar with this review and the type of problems on it, you're going to be well on your way to doing well on the test. I will post the results, the printed version of this online as well. I would encourage you to have it handy. I would encourage you to have some important bits of information handy, like Principles of Logarithms handy. Anything that you think of that might, remember this sheet, the basic properties of logarithms. Anything that you think might be helpful to you as you take the test, have that handy, so that your 2.5 hours is well spent. Just like the last time and just like before, any question that deals with asymptotes, just don't worry about it. It will not hurt your final grade. I will not count that question against you. If you're already an asymptote whiz, help yourself to it, and that will be extra credit, but do not worry about the asymptote problem. There's one on the test, since I chose to skip that section. All right, here's the schedule for your section. You're going to have to know which section you're in and when your test is due. You will have 4 days in which to choose your testing time. Your, 150 minutes to invest on your final exam. If you're in section 1, anytime from Friday, May 8th to Monday, May 11th at midnight. Don't wait till the last minute. Once again, the only way that problems happen, last minute problems happen, is if you wait till the last minute. So give yourself plenty of time in case a question comes up. If you're in section 4, anytime from tomorrow, Tuesday the 5th, through Friday at midnight, you may take your test. And if you're in section 12, anytime from Saturday, May 9th through Tuesday, May 12th at midnight. This will be in your notes, so you are free to refer to that once we get going. All right, here we go. Solve the following linear equation. You know what you're going to be doing first here is a little bit of distributive. Use those calculators, negative 16 times 7. So you did your distributive first. I got z's on both sides. I have numbers on both sides. You remember the principle. I would encourage you to get the z's on the side that has more z's, that being this one. When you move a term, change its sign. Move a term, change its sign. That's 1z. I would just put z. 112 minus 10, 102. Solve a simple linear equation. Number 2, solve this equation, this formula for r. There's my r. I need to get it by itself. If I'm solving for r, that means get r all by itself. It's being multiplied by 2 pi Divide both sides by 2 pi. And I get r is c over 2 pi. You're probably noticing, hey, we did this stuff a long time ago. That's right, the final exam is cumulative. It covers the entire semester. All right, your check comes to $24.43. You want to leave a 14% tip. Why are you leaving a 14%? Because that makes the problem more difficult. What total should you leave? All right, first you got the $24.43. Here's where you remember that 14% is 0.14. Make that multiplication, and you get $3.42. What total should you leave? Well, I better add $3.42 plus $24.43, and I get $27.85. The concept to remember here is percent. Move the decimal over 2 places to get the decimal representation. Solve the inequality and express your answer in interval notation. This solves just like an equation, just a slight difference. My encouragement to you is always get the variable on the left so that the variable itself can be the subject of your inequality sentence. So I'm going to move a term and change the sign. I'm going to move a term and change the sign. That's just n, and that's 4.8. So n is less than, that's why we put the n on the left side so it can be the subject of the sentence. N is less than 4.8. To graph that, you're going to go to your Hawk's graph. You're going to find 4.8, and you're going to shade everything to the left. Question, what kind of ending marker do I use? There's no equal sign, so I'm just going to use parentheses. There's my interval notation. Whoops, that's not interval notation. That's the graph. Interval notation is going to be this guy. It's going to be everything from negative infinity all the way to 4.8. And since there's parentheses there, there's parentheses here, and there's always parentheses with infinity symbol, right? So this is the interval notation. Excuse me, that's the graph. All right, plot these points. So you're going to find your the graph that's given, and you're going to plot those points. You got one in each quadrant. No big deal. I think you can handle plotting points. Remember, left to right movement first, up or down movement second. All right. Number 6, find the X and Y intercepts of this particular equation. And you probably remember, if I'm going to find the X and Y intercept, I let the other variable be 0. To find the X-intercept, let Y equal 0 and solve for X. So that means the Y term becomes 0, and I solve for X. Divide by -3 on both sides. X is -3. Secondly, let X equal 0 and find Y. If X is 0, the X term is 0. I get 6Y is 9. Divide both sides by 6. Y is 9 over 6. But this is not my first algebraic rodeo. I do not leave it as 9 over 6. I leave it as 3 over 2. And if it asks you to express the X and Y intercept as points, then you will simply go -3, 0 as the X-intercept and 0, 3/2 as the Y-intercept. All right, find the slope of the line. All right, here's where you remember a couple of things. Number one, if you only have Y values in it, do you remember what kind of line that is? This is a horizontal line. And a horizontal line has a slope of 0. If, for instance, you had an equation with just x's in it, you got yourself a vertical line. And every vertical line has a slope that is undefined. If it's got x's and y's in it, then you're going to do what we're going to do on number 8. That is, we're going to express it in slope-intercept form to find the slope. But if you just have y's or just have x's, remember these two concepts. All right, number 8, express in slope-intercept form. That means I need to express it as y equals mx plus b. When I do, that will be my slope. So let's do a little distributive. Let's see. I'm going to get my y by itself. So I'm going to add 1 to both sides. Did I do that right? Oh, look carefully. That's a -3. Sorry, this is tiny. -3 times 4, -12. -3 times -2 plus 6. Apologies. Don't have my glasses. All right. So 7y is, I'm going to put my x's first. I'm going to move that -1 to the other side and +1. I need to be in the form y equals, so I'm going to divide every term by 7. And there's my slope, 6/7. Express in slope-intercept form, we did, there it is. And you know that means that 6/7 is the slope, and that the point 0, -11/7 is the y-intercept. All right, now, second part to this question. Find the equation of the line passing through that point, -1, -12, and parallel to this line. First concept to remember. Lines that are parallel have the same what? Yeah, slope. So this line that I'm interested in has a slope of 6/7, same as this one. So I've got a point, and I've got a slope. Look what I got, an x, a y, and an m, which means I have an x, a y, and an m. I have everything but b, so I'm going to substitute these 3 values here and solve for b. So y is -12, m is 6/7, x is -1 plus b. This is ugly. -12 equals -6/7 plus b. So b is going to be, moving this to the other side and changing the sign, -12 plus 6/7. Turns out that's -11 1/7. So that's my b. That's my m. So the equation of my line is y equals m times x plus my b, which is minus 11 1/7. Once again, I'll have all these notes in more detail. I will put that on your content page, quickly content. So I would have this run off in front of you. So when you take your final exam, you can refer to the type of problem that you see. All right, number 9, find the domain and range of the following relation. Now this relation is just 4 different ordered pairs, and I remember that the domain is the set of all first elements. -3, 1, -3, I don't need to repeat that, -3, 1, and -2. And the range is the set of all second elements. 0, -5, -2, -1. So there's the domain and the range. First elements, second elements. Now, determine if the relation is a function or not. Here's where we have to remember that a relation is a function if no first element is repeated. Yeah, well, I got a first element repeated. Look at there. -3, 0, -3, 2. This guy is not a function. If it's not a function, give 2 points as proof. There are my 2 points. -3, 0, -3, -2. I cannot have the same first element in a function. So this is just a relation, not a function. All right. Oh, sorry. Where'd it go? Anybody see where I put my, oh, you probably can't see. All right. Number 10. Consider the following function. Find the vertex. Now, some of you will remember that this is our typical quadratic function. It defines, it graphs into a parabola. This one has a positive coefficient, so that means it is an upward turning parabola, a U shape. Notice it's also in what's called vertex form. Vertex form means it is in the form f of x equal x minus h squared plus k. Remember that hk? The vertex of my parabola. And to find the vertex, I take the opposite of this and the same as that. So whatever this number is, it's -4. I take the opposite of that and this number as it's written. So there's my vertex. Opposite of this, same as that. All right, find the X-Intercepts, if any, and express as ordered pairs. Remember, X-Intercept is where y is 0. Well, if you look at this, I don't see a y. Most of you remember that f of x is the same as y. So in the place of f of x, I'm going to substitute y. Now, X-intercept means I let y equal 0. and solve for x. Okay, first thing I'm going to do is add 4 to both sides. And I get 4 is x minus 4 squared. To get x by itself, I got this thing squared. I'm going to take the square root of both sides. Square root of this, square root of that. So square root of x minus 4 squared is just x minus 4. Square root of 4 is 2, but I'm going to remember to put plus or minus. Don't forget your plus or minus. This gives me 2 equations to solve. X minus 4 equals 2. X minus 4 equals negative 2. Add 4. I get x is 6. I get x is positive 2. So there are my 2 x-intercepts. Expressed as ordered pairs. All right. 6, 0, 2, 0. All right. Find 2 points on the graph other than the vertex 0, 0 and these 2 x-intercepts. So once again, I'm going to use y is. And I'm going to pick an x and find a y. Let's see. Let's pick 1. 1 minus 4 is negative 3 squared. Let me just show you here. 1 minus 4 is negative 3. Negative 3 squared is 9. 9 minus 4 is 5. So you're going to pick an x and you're going to solve for y. I can't use 2. It's already part of my solution. So I'll take 3. 3 minus 4 is negative 1. Negative 1 squared is 1. 1 minus 4, negative 3. Did I do that right? 3 minus 4, negative 1. Negative 1 squared is 1. 1 minus 4 is 3. Negative 3. All right. So note this form again. This is in vertex form. The vertex is revealed when you see a quadratic equation function in this form. All right, consider this function. H of x equal 4/5 times the absolute value of x. Now you're going to have to identify the general shape of this graph. What I would do if I were you is to find your worksheet that has the 9 basic function graphs. That should be something that you have. The 9 basic function graphs will show you that an absolute value with a positive coefficient is an upward turning v. So when you identify the general shape, it is an upward turning v. Now it says find 2 points on the graph other than the origin that fit on the graph given. Now this is going to be important because the graph that you're given is not infinite. It's got like a 10 by 10. So you can go only 10, 10, negative 10, 10, negative 10. It is a limited graph. You're going to have to pick 2 points that fit on this graph. So assuming that 10 is the largest value I can choose, I want to pick a couple of x's and find some y's. Remember, h of x is the same as y. Hey, and think about it. I'm going to be taking 4/5 of something. So the something, it seems to me, would it'd be nice if this something was divisible by 5, because I'm going to take 4/5 of it. So let's pick 5 for my x. Absolute value of 5 is 5. 4/5 times 5. I'm going to put 5 over 1. My 5's cancel. I get 4. Let's pick negative 5. Remember, I want something that's a multiple of 5. So absolute value of negative 5 is also 5. 4/5 of that is also 4. There are my 2 points. Neither one is the origin, and they fit on the graph. All right, number 12. If the function f evaluated at 1 is 15, f of 1 is 15, and g evaluated at 1 is negative 15, find these guys. These are my combined operations: the sum, the difference, the product, and the quotient function. This is where you remember that f plus g of 1 simply means f of 1 plus g of 1. It's that simple. Hey, I know what f of 1 is. It's 15. And I know what g of 1 is. It's negative 15. Add those two together. Got it. F minus g of 1 is simply defined as f of 1 minus g of 1. I know what f of 1 is. Minus g of 1. Don't forget your extra subtraction there. Minus a negative. I got it. F times g of 1. That simply means f of 1 times g of 1. F of 1 is 15. G of 1 is negative 15. Positive times a negative, negative. Make sure you get your calculator handy. Again, f over g of 1 finally is f of 1 over g of 1. That's all that means. I know f of 1, it's 15. I know g of 1, that equals negative 1. So that's the idea of combining functions. Have that little definition handy with this sheet here. All right. There's one other combination of functions called the composition of functions. Remember this guy? This is a little bit different. And our definition of f of g of x simply means the first function evaluated at g of x. That's what the composition of functions means. F of g of x means the first function evaluated at the second function. So I basically have two things to do. I'm going to find what g of x is. I can do that without any problem. Then I'm going to, whatever I get there, evaluate f at that particular value. They want specifically f of g of 4. So f of g of 4 means the function f evaluated at g of 4. So I first have to find g of 4. Now look what g of x is. G of x is 3 plus the square root of x. So g of 4 means 3 plus the square root of 4. Whatever my x is goes here and here. That's 3 plus 2. That's 5. So g of 4 is 5. So now I need to find f of g of 4, but wait a minute, g of 4 is 5. So I got to evaluate the function f at 5. Here's my function f. F of 5 means the square root of 5 plus 4. Wherever there's an x, in this case, I'm putting a 5. That's square root of 9. What do you know? That's 3. So here's the definition of composition of functions that will remind you what to do when you are composing two functions. All right, consider the following polynomial. Notice it's in unorganized fashion. It says, first of all, express in descending order of exponents. That's called standard form. So we put the largest exponent to smallest. So 6y to the 14th minus y11 so I put it in descending order, 14, 11, 4, and 0. Then identify the degree. Now you probably remember that the degree means the largest exponent. So the degree is simply 14. Then it says identify the leading coefficient. And hopefully you remember that the leading coefficient is the coefficient of the leading term. So it's not 6y to the 14th, it's just 6, the leading coefficient. All right, factor if possible. If not, say not factorable. Notice there's a 1 in front of the x squared. That means I'm looking for two numbers that multiply to give negative 32, add to give a positive 4. Not a lot multiplies to give negative 32. But the two we're interested in is either negative 4 and 8 or 4 and negative 8. Which pair also adds up to positive 4? That's the pair that add to positive 4. So my two binomials are going to be x minus 4 and x plus 8. So this guy did factor, minus 4 plus 8. Same thing here, factor if possible. Now you'll probably notice this is the difference of two squares. Difference of two squares always factors. It always factors into two binomials. Square root of this guy, here and here. Square root of this guy, here and here. Always a plus and a minus. So the difference of two squares always factors. Hey, do you remember this? Sum of squares. Remember anything about the sum of squares? Yeah, it doesn't factor. It's prime. Keep that in mind in case the sum of squares shows up. All right, solve by factoring, or if you can't factor it, use the quadratic formula. Well, it doesn't take us long to look at 41 to realize that there are no two numbers I can multiply to give 41 and add to give negative 5. So I'm going to have to use the quadratic formula. Remember it? Minus b plus or minus the square root of hopefully you'll have this guy handy in case you haven't memorized it. So what that means is I need to identify A, B, and C in this particular quadratic equation. A is the number in front of x squared, B is the number in front of x, C is the constant number. So A is 1, B is negative 5, don't forget the sign, and C is 41. So all I have to do is fill this guy in and see what happens. X is the opposite of B, that makes it a positive 5. Plus or minus, that's how I'm going to get my two answers. B squared is always going to be a positive number since it's squared. So negative 5 squared is 25 minus 4 times A times C. All over 2 times A. All right, so now I got to do a little multiplication, little subtraction, figure this guy. You get 5 plus or minus see, 4 and 4 and 164 minus. Uh-oh, looks like this is going to be one of those I values, huh? Because I'm going to get a negative number under the radical. Use your calculator when you need to, and I would use it at every occasion. Now it says solve, so here we go. We're going to solve this guy. 5 plus or minus. I'm going to take out the -1. The square root of -1 makes this I. And that's square root of 139 all over 2. So there are my 2 solutions. If they give you 2 blanks to fill in, then put 5 plus that over 2 and 5 minus that over 2. Otherwise, you can use the plus or minus. All right. Let's do number 18. It says identify the graph and X and Y intercepts of the following. Now, some of you would recognize this as a quadratic function, which means it is going to graph into a parabola. The number in front of x squared is positive, so it's going to be an upward turning parabola. And I'm going to find out what this guy looks like by finding the X and Y intercepts. Remember how to find a y-intercept? You let x equal 0 and solve. Remember, g of x is the same as y. So I'm going to let x equal 0 and solve for y. This is easy. Y turns out to be -2. So my y-intercept is 0, -2. Which means on my graph, my y-intercept is the point 0, -2. All right, let's find our x-intercepts. To find an x-intercept, I let y equal 0. So y is 0. All right, I need to solve this guy. And you might recall set to 0. It's already done. Number 2, factor. Does it factor? Hey, thank goodness it does. So I'm looking for 2 numbers that multiply to give -2, add to give a +1. That's going to be x plus 2, x minus 1. These 2 numbers multiply to give -2, they add to give a +1. So factor. Thirdly, set each factor to 0 and solve. So x plus 2 equals 0. X minus 1 is 0. Subtract 2 from both sides. Add 1 to both sides. So I have my 2 X-intercepts. So in point ordered pair form, -2, 0, and 1, 0. So identify the graph, express points as ordered pairs. So my 2 X-intercepts are at -2, 0, and at +1, 0. So I have these 1, 2, 3 points given. And should you want to find some other points, it's not difficult. For instance, if I want to find what happens at 2, if x is 2, just let x be 2. 2 squared is 4. 4 plus 2 is 6. 6 minus 2 is 4. So if x is 2, I get 1, 2, 3, 4. If x is 3, 3 squared is 9. 9 plus 3 is 12. 12 minus 2 is 10. So if I choose x is 1, 2, 3, I get 10. So I can find some other points should I choose to. But basically, I'm looking for a graph that has x-intercepts at -2, 1, and a y-intercept at 0, -2. So you find the graph in your choices that satisfies those two conditions, and you got it. All right, similar to the last one. Identify the graph and x and y intercepts of the following. Express points as ordered pairs. So this guy is already factored. I have set it to 0. Here's my y. So here's my expression in terms of y instead of g of x. So to find the y-intercept, I let x equal 0 and solve for y. So y is going to be 0 minus 2, 0 plus 2, 5 minus 0. Y is going to be -2 times 2 times 5. It's -4 times 5. Turns out to be -20. So my y-intercept is the point 0, -20. So whatever my graph looks like, it goes through the point 0, -20. So it's going to go through the point 0, -20. How about my x-intercepts? Again, to find the x-intercepts, I let y equal 0. This is already nicely factored for me. So all I have to do is my third step, set each factor equal to 0 and solve. So that gives me x is 2, x is -2, move the negative x to the other side, x is 5. So there are the 3 places this graph cuts the x-axis at 2, 0, -2, 0, and 5, 0. Hey, you might want to have a little graph paper handy just so you can kind of sketch these guys. This graph goes through 2, 0, -2, 0, and 5, 0. So it's going to be a roller coaster. But look here, this 20 is in between these two guys, so I know it has to go down to my y-intercept and back up. And it goes through that point. It's got to go up some more. I don't know how much. I don't care how much. And this guy keeps going up. So my graph is going to look like that. It goes through these points. So that's what the graph is going to look like. And you're going to pick the graph that looks like that. All right, that's number 19. You see now why you're going to need 2.5 hours, don't you? Find the restricted values for x. If no restrictions, say no restrictions. All right, you're going to remember, hopefully, that restricted values are wherever the denominator is undefined. And the only thing that makes a denominator undefined is if it is 0. So you're going to take the denominator, just the denominator, and you're going to set it equal to 0 and solve. So I get 7x is negative 3. Divide both sides by 7. And my one restricted value is negative 3/7. That's it. Set your denominator equal to 0 and solve. All right, consider the relation. Again, 1, 2, 3, just 4 different ordered pairs. First of all, find the inverse and express as ordered pairs. Now, what you're needing to remember here is that the inverse of any relation simply reverses the ordered pairs. So my ordered pairs are now not negative 10, 10, but 10, negative 10. Not negative 9, 8, but 8, negative 9. Not negative 3, 5, but 5, negative 3. And 7, 4. So that's not hard. To find the inverse of a series of ordered pairs, simply reverse the ordered pairs. Now it says find the domain and range of the inverse. So here's my new relation, the inverse, or inverse. And remember again, the domain is all the first elements. So the domain of my inverse is 10, 8, 5, and 7. And the range is negative 10, negative 9, negative 3, and 4. Not too tough. All right, number 22. Simplify using properties of exponents. Look what you got here. 5 in parentheses, 3ab cubed, all of that to the 0 power. It says express your final answer with positive exponents only. Here's the concept you're going to need to remember. Anything to the 0 power is 1. That's right. So whatever this is to the 0 power, that's simply going to be 1. Not too challenging, huh? Hey, if this happened to be a 2, remember what you're going to do. Multiply your outer exponent by each of the inner exponents. And if there's no visible exponent, for instance, if you had 3ab cubed, if you had that squared, you would multiply the outer exponent by each of the inner exponents, even when they're invisible. So I get 3 squared, a squared, be the 6th. And I typically say 9, a squared, be the 6th. All right, simplify the following expression. Notice what I have. I have a fractional exponent. Here's where I think I gave you the example of 8 to the 2/3 power. Remember that? Where we expressed a fractional exponent in radical form. The base becomes my radicand, the denominator becomes my index, and the numerator becomes my exponent. With that concept in mind, I am going to re-express 25 to the 1/2 in radical form. The base becomes my radicand. The denominator becomes my index. The numerator becomes my exponent. Now, I typically don't write 25 to the first. I just write 25. And I typically don't write a square root with a visible index. So this is simply the square root of 25. And there's my simplified expression. Remember, if this happened to be negative 9 to the 1/2, you'd say, well, that's the square root of negative 9. And then you would choose that not a real number, since that is an I concept, a complex number, you'd say not real. If you get a negative under the square root. All right, this is going to be a big-time calculator problem. A population of an inner city is declining according to the following function. The population P of t equals 203,000 times e to the negative 0.014 t, where t represents the number of years from the present. Question, find the population in 14 years. So my t is going to be 14. And it says round to the nearest person. So here's what you're going to find. You're going to find P of 14, what you want, Epi, equals, I'm being distracted by my dog here, e to the, hey, you're going to have to find your e to the power of key, .014, negative 0.014 times t, which is also 14. So you got several things to do here. You're going to have to find out what negative 0.014 times 14 is. That's calculator work. Then you're going to have to take e to that power. Now that means you need to find your e to the power of function key on your particular calculator. Mine is right here, a second function key to the ln, natural log function key. It says e to the x. So first thing I'm going to do is find out what negative 0.014 times 14 is. That's calculator work. You want to go outside? I'm going to put my dog outside. I'll be right back. All right, so P of 14 is 203,000 times e to the negative, and when I multiply 0.014 times 14, I get negative 0.196. Now here's something you're going to want to keep in mind. When you do e to the negative 0.196, for those of you that have a calculator that look like mine, do not use this subtraction sign for a negative. Use the negative sign, otherwise you're going to get a error expression. So use this. So I'm going to go second, natural log, there's my e to the power of what? Negative 0.196 equals. So I get 0.822012235, something like that. I can just leave this in my calculator, multiply by 203,000. And I get 166,000. 868. 0.4, so I'm not going to round it up, so that's going to be my to the nearest person idea. Again, find your e to the power of function key, because you're going to need that on your test. All right. Getting closer. Use the properties of logarithms to solve the following equation. Now here's where I will include these two sheets in the notes that I put on Quickly Content. Here's where you're going to need the logarithmic to exponential form difference. I have a log of something, I want to solve it, and I'm thinking, I'll bet if I put it in exponential form, I'll be much better off. So here's what you need to remember. Log base x of a equals b, that's what I have here, log base x of a equals b, is the same as, or may be changed to, x to the b power equals a. These two equations are equivalent. One is in logarithmic form, one is in exponential form. I have that for you right here with an example. I'll include these. So if I was you, I'd run this stuff off, have it handy. So I'm going to use this transformation from a logarithmic expression to exponential with this guy right here. So it's going to be the base to that power equals 5x. That's how I changed logarithmic expression to exponential. That to that power equals that. Hey, well, I know what that to that power is. 3 to the third is 27. Look at this. All I got to do is divide both sides by 5, and I got it. So x is 27/5. Express any fraction in lowest terms, 27/5. But notice the key. The key is changing this logarithmic expression to exponential. All right. Use the properties of logarithms to condense the following. Here's where I remember, look here, I got a log minus a log. Here's where I remember that a log minus a log is the same as the log of the quotient, the fraction of these two things. And that's what I got here. I got a log minus a log. So natural log z minus natural log of 10x, that's just natural log of a fraction. That over that. Well, that was hard. So difference of logs is the log of a quotient. All right, next one. Solve the exponential equation and express as exact and decimal approximation. So I need to express both in exact form, that is before I enter into my calculator, and as a decimal approximation to 2 decimal places. All right. Notice what I got here. I've got an exponential expression. This doesn't help me. This would help me if I could express 1299 as 8 to some power, and then I'd have the same base. But 1299 is obviously not 8 to some power. So I'm going to translate this guy from an exponential form to a logarithmic form. And here's what I get. It's log base 8, log base 8 of 1299 is x minus 4. That is using this, the transformation between exponential and logarithmic forms. All right, this is obviously not very helpful. Why not? Because I do not have a log base 8 function key on my calculator. But I do have a formula that allows me to deal with something like this. It's called the change of base formula. And here's what it says. If I have an inconvenient base, how am I going to find log base 5 of something? I don't have that function key on my calculator. I can change this to a familiar base, either common log, base 10, or natural log, base e. Why? Because I have calculator function keys that will allow me to find this. So I'm going to use just log base 10. This says log base 8 of 1299 is the same as log base 10 of 1299 over log base 10 of 8. And why did I change that? Because I can do this on my calculator. Log base 10 of 1299 is as simple as saying log 1299 equals. And I got 3.11 something. I'm just going to leave this here. I just did log of 1299, and I got it here, 3.11, 3609, etc. Now I'm going to divide that by log of 8. Log 8 equals. And what I get is 3.44. 7728572 is equal to x minus 4. So I get this ugly number here equal x minus 4. This is where I'm going to get my exact value for x. This is x minus 4, so I'm going to add 4 to both sides. So I get 4 plus 3.44772857. Oh, you know what I'm thinking? This is not exact. This is an approximation. So to get the exact value, this is what I'm going to use. This is exact. This is exact. So I'm going to add 4 to both sides here. This will give me my exact. So I get log 1299 over log 8 plus 4. That's my x. So there's my exact value right there. That's what they want for exact. Don't simplify the logs yet, or don't approximate the logs yet. When I get the decimal approximation, that's what I'm doing here. So this is 7.447728, etc. To 2 decimal places, x is approximately equal to 7.45. So here's my approximation to 2 decimal places. Here's my exact. $7.45. All right, solve this expressed as exact or decimal approximation to 4 decimal places. So you have a choice here, exact or decimal approximation. All right. Hey, the first thing I note here is I have a log base 5 of something minus a log base 5 of something. Same thing I had here. Log minus a log is the same as the log of the quotient, that divided by that. So far, so good. This doesn't help me a lot. So what I'm going to refer to is, again, the transformation of a logarithmic expression to an exponential expression. What I did in 25 here. I'm going to change this to that power equals that. Hey, this looks almost doable. 5 squared, that's just 25. I'm going to put 25 over 1 if you don't mind. Why? Oops, that's a minus. Sorry. Why? Because I'm going to cross multiply to solve for my x. So 25 times this equals 1 times that. That gives me 25x. More x's over here, so I'm going to move it and change the sign. Move that and change the sign. So I get 24x equals 49. X is 49 over 24. Notice decimal approximation to 4 decimal places. I guess we could do exact. Here's the exact. If you like exact, if you did the decimal, you get something like 2.04167 to 4 decimal places. I'd get 4 decimal places. Exact or 4 decimal places. Now, listen carefully. When you get a problem like this where you have logs, you have to make sure that the thing you're taking the logarithm of is positive. If your x causes this or this to be negative, then you have to say no solution. So my x is 2 point something. 2 point something minus 1 is 1 point something. That's good. That's a positive number. 2 point something minus 2 is still a positive value. This is good also. So this checks out as a good solution. But keep in mind, if x was equal to 1, and I got 1 minus 1, or I got 1 minus 2, that would be a negative value. I'd have to say, sorry, there's no solution here. So be sure and check to make sure you do not get the log of a negative scenario. That would imply no solution. Again, check to make sure your x does not give you the log of a negative. All right. Last two. And by the way, I've only got 30 instead of 31 because I left off the asymptote question. When you see the question that has the word asymptote in it, you can just skip it because it will not count against you. All right. Here is the last concept we went over, which was solving systems of linear equations by substitution or elimination. Hey, and by the way, remember, if it says use substitution, you are free to use either substitution or elimination, whichever one you like. This guy makes sense to use substitution because one of the equations is easily solved for x or y. So first thing I'm going to do is take this guy and solve it for y. Divide by -4. So y is -33/4. So I've already got half my solution set. Here's my y. I need to find my x. Obviously, what I'm going to do is substitute. In the other equation, everywhere I have a y, I'm going to put -33/4. So I have -x minus 5y equals -29. Everywhere I have a y, I'm going to put -33/4. using my calculator, -5 times -33/4. I get plus got my x's all by themselves over here, so I'd like to move this to the other side and change the sign. Now I got to add -29 to -165/4. Remember, I moved it and changed the sign. So I'm going to change -29 to something over 4. I'm going to multiply 29 by 4 to see what it is. And this turns out to be -116/4. Just to get a common denominator so I can combine these two guys. Again, I multiplied -29 by 4/4. It gives me -116/4. So now I can combine my numerators. -x is -281/4. It's -x. I want x, so change the sign of both. 281/4. Ugly, but the solution. So my solution, my point of intersection of these two lines is the point 281/4, comma, -33/4. Leave fractions as fractions. All right. Last problem. Use substitution to solve. But you know what? I'm not going to use substitution. You know why? Because I'm looking at these first two terms and I'm thinking this would be very easy to make the opposite of that, wouldn't it? So if this was -8x, that would be the opposite of that, which means all I have to do is multiply this guy by -2. So I get -8x, -2 times 8y minus 16y. -2 times -8 equals 16. Leave the second equation as is. Isn't that going to be easier than substitution? So once again, if it says use substitution, it's up to you. Use substitution or, as in this case, elimination. Opposites. Add my like terms. That's -14y equals 28. Divide by -14. Y is -2. Then in either equation, I'll take the first one. Substitute y, -2 for y. And let's find out what x is. Add 16 to both sides. And I got the x by itself. Divide by 4, x is 2. So the point of intersection of these two lines is the point 2, -2. All right, once again, I will put all this information as well as the logarithmic help sheets on quickly content, and I will post this video. Please be familiar with this type of problem. If you are, I can guarantee you'll be familiar with the problems on the test. I will not be giving out partial averages. As soon as your test is finished as a class, I will figure the grades and I will post that on Banner a self-serve banner. So good luck to you. Give yourself plenty of time. Remember, it's 2.5 uninterrupted hours. I have your notes handy, and I'll see you on the other side.